So I'll let Jason go ahead and do our introduction.
Welcome everyone to our first seminar of the semester. I'd like to introduce Erin Rinehart. Her and I were classmates in grad school together. And she's now an aviation forecaster. So she'll tell you all about that. Take it away, Erin.
All right. Thanks, Jason. I appreciate it. So we're going to do a quick Q&A here. How many of you have traveled by airplane? Show of hands. All right. So how many of you already knew before you came into this lecture that airlines have dedicated meteorologists to do the forecasting for their operations? Okay. You're better than the general public, because when somebody asks me, hey, what do you do? And I tell them, they say, oh, I never in a million years thought that airlines would have their own meteorologist. And all I can think is, why? So one of the big things about forecasting for the airlines is it's going to be much more, precision forecasting than what you get from your broadcast stations, than what you see on weather.com, AccuWeather, wherever you go on your phone app to get your weather forecast for the day. What they're doing with the mass media forecasts is they're forecasting for the general area. That's probably not news to you. What we do when we write a forecast for an airport, or we're helping out with a flight, trying to figure out, is there turbulence, is there icing, are there any sort of hazards in the air that are going to impact this aircraft? We have to be a lot more precise. For an airport, we're only forecasting for a 5-mile radius. It's a precision forecast. For the aircraft, if somebody says, hey, is there turbulence? We're looking at whatever flight level they're in. If they're flying at 30,000 feet, they don't care if there's turbulence at 15,000 feet. So it's a lot more precision than what you get from the media. And that's something that you kind of have to get used to, and you really have to hone your forecasting skills to get to the point where you can do that more accurately. And one thing that helps us do that is the way we do our forecasts. You know, we write what's called a TAF, a terminal aerodrome forecast. And that is basically forecasting for the airspace of the terminal. It's literally what it sounds like. So we're going to go over those a little bit later. We're going to talk about observations. You may or may not have sseen METAR observations. Those are the coded obs that get spit out by the airports. We're going to talk a little bit about, what was the difference between civilian aviation forecasting and military aviation forecasting. I did a little bit of time in the Air Force. So that's where I learned how to forecast, and I learned all of these skills that I'm now putting into practice with Southwest Airlines. And I'm going to start, though, by talking a little bit about how I got where I am. I did not take a traditional educational route, so it was a little more convoluted than what most people do. It wasn't just undergrad, grad job. So I did start with my undergrad. I went to Baylor University, and I didn't really have a purpose in life. It was just, oh, I'm supposed to go to college, so I went to college. I didn't know what to do. I didn't really seem to be that good at math, so all of the plans that I originally had kind of went out the window, and I decided to just get a degree in earth science, which was a BA, which does not help me get a forecasting job anywhere. So since I graduated kind of at the start of the recession, it was, going into 2006, I decided, hey, let's join the military. My granddaddy did it. I'd love to do it too. So I went in and I talked to a recruiter, and I was like, hey, I have always wanted to be a meteorologist, but I'm not that good at math. So, I went and took the test, and he said, well, you're good enough to do it for the Air Force, so let's get you a job. So I joined the Air Force as a weather forecaster. And it started out with a 9-month technical training, which is the second longest school in the Air Force for technical training. That is where I learned about all the things that you're doing in your undergrad, the intro to meteorology stuff, learning about METARs, learning about TAFs and all these different codes, learning how to look at and interpret models, a little bit of synoptic meteorology, not much dynamic meteorology, because again, this is not a math heavy, how do we model the atmosphere? It was more of a forecast heavy, how do we interpret models and use that data to give a forecast to pilots so that they can go get the job done. They didn't care so much about whether we understood how the model worked. They just wanted us to know how to use it. So when I got into the military, I spent a few years doing that in Shreveport, which was not the greatest place in the States to live. Vermont's far superior. All of Vermont, even Rutland. So after doing that for a few years, I said to myself, I want to do more. So I decided to go to graduate school. I enrolled in the Mississippi State program, which some of you may have heard of. Their master's in geosciences, because I felt like that would be a good add-on to my earth science background from my undergrad. And after doing that for a year or so, I realized that I really wanted to dig deeper into this, and I wanted to be enrolled in a program and actually be physically there, not just do this online school. It's fine for me for a couple of classes, but I wanted to be in the classroom. So after I finished my enlistment, I joined the National Guard and moved up to New England and started taking a bunch of those math classes, because now I know my purpose in life is a meteorologist, but I still don't feel like I'm good at math. So I spent 2 years just taking undergrad math classes until I had DiffEQ all squared away. And then I was able to enroll in a master's program. While I was in the Guard, though, what I was able to do was go down and do an observer school, where I learned how to take an observation without having to use a machine. Just go outside and do it yourself with a Kestrel. I'm sure some of you have seen those. Have you gotten to play with those yet? Okay, good. Those are fun. So we got to learn how to do observations. And since my Guard unit was an Army support unit, I got to do combat weather, which was really cool. And I'll cover a little bit more about that when I get to the military part of the forecasting. So I basically spent 1 weekend a month down doing forecasting for the military. And the rest of my time I was up at Plymouth working on my master's. I did that for a couple of years. And then when my Guard enlistment ended, I just parted ways with the military and decided that I'm going to pursue this 100% civilian forecasting. This is what I want to do, and I'm going to find a way to make this work. So when I left, or before I left Plymouth, my last semester, sorry, dog, lay down. My last semester, I did an internship at Boston Center. Now, I don't know how familiar you are with the National Airspace System as far as the air traffic control is concerned. Tesla, come. He's going to eat cat food. Tesla, come. Good girl. Lay down. Sorry about this, guys. And so, here, peanut butter. Hey, peanut butter. You're messing up. Hey, look. Oh, look at that. Have fun. Okay. So when I was doing my internship, I was at the Center Weather Service Unit, which is embedded with the Boston Air Traffic Control Center. Now that's located in Nashua, New Hampshire. So I am going to share the PowerPoint real quick, if I can find it. There we go. All right, are y'all seeing the PowerPoint now?
Yep. Yes.
Okay, excellent. So I was working at Boston Center. That would be the middle portion right here where it says Air Route Traffic Control Center. What they do is they're in charge of dealing with airplanes coming in and out of the airspace over the general Boston and New England area. So this is the Boston airspace up here, ZBW, New England, part of New York. They're in charge of all of that airspace. So what they do is internationals come in, or we've got flights coming up from Miami, and they get through all of these different centers and they get up into Boston airspace. Boston would take over routing, dealing with those flights, talking to the airlines about any issues going on with those flights. They're the ones controlling the flights in that airspace. So that's where I did my internship. Each one of these centers, all 20 of them, have National Weather Service forecasters working at those locations, and they do specialty forecasts for the airspace. They look at icing and turbulence. They look at any sort of convection that's going to be in the area that thunderstorms are going to have to steer clear of, and they report back to the traffic management unit, which sort of runs the center, as to where the hazards are going to be for the day. And then the traffic management unit, the TMU, can then go and figure out where do they want to route planes. There's routes all through each center across the country, and they just figure out which routes are going to be open and available to planes, which ones are going to have hazards, do we need to close those routes for the day, things like that. So then you've got the terminal arrival, that's TRACON, and that was also located, interestingly enough, close enough that I could go and do a day there. I don't remember what town that was in. But if you're going to fly, we're going to pretend like we're flying from Boston to Dallas. You're going to get on the airplane, you're going to taxi, you're going to take off. The people controlling the flight at that time are the tower at the airport, and they're in charge of just the local airport airspace. Once they hit 10,000 feet and you can turn on your electronics, they're handing that flight off to what's called the TRACON. The TRACON is what you see inside the largest green ring. So this is the Boston TRACON. While you're in this area and you're rising to cruising altitude, the TRACON is taking care of you and telling you how they want you to exit the general Boston airspace. For all the flights coming into the airport to land, the TRACON is telling those pilots which direction they want them to enter the airspace. And it's basically to facilitate all of the aircraft in and out of the greater Boston airspace. And any of those smaller circles that you see within there are going to be smaller regional airports that the TRACON also will facilitate the arrivals and departures once they leave the tower's airspace for those smaller airports. So we take off from Boston. We turn on our electronic devices at 10,000 feet as they hand over to the TRACON. And then once we're out of that Boston airspace, getting closer to cruising altitude, Boston Center, where I did my internship, takes over. So we're going to go from Boston to Dallas. So we're going to travel through ZBW, probably route us around because New York Center is incredibly busy. They don't want any more traffic in that airspace than they absolutely need. So if routes are good, we'll travel down to Cleveland Center, ZOB, then maybe Indianapolis Center, ZID. We may come down through Atlanta Center. We may come down through Memphis Center, or both, to get down to ZFW, which is Dallas, Greater North Texas Center, really. So once we hit this area, we're going to go into our descent. Once we reach a certain distance and we're lining up to come into the Metroplex, we're going to see the Dallas TRACON airspace. So this is what we call a corner post, and this is where my job gets really busy. Not only do I have to forecast for the terminals, I have to forecast for all of the arrival fixtures, which are these 4 that are named, and all of the departure fixtures, which is the opposite north, south, east, west, rather than being on the diagonal. So the cardinal directions for Dallas are departures, and the diagonals are our arrivals. So if there's a cluster of thunderstorms sitting on Bonham, all of a sudden we can't put aircraft through this area, and all of the air traffic that would normally be coming in, say from the northeast, now has to funnel down around to the southeast or over and around to the northwest. So then you get congestion at the northwest and southeast corner posts. That starts to slow down arrivals. That starts to slow down the airplanes that are still in the air, but now are moving too fast and getting too close too quickly. So now you need to slow down aircraft that may be in another center's airspace so they don't get to Dallas too soon because everything is getting sort of bunched up on each other. So there are all kinds of different plans that they can put into place to what they call meter the flights. And you can meter an airport, or you can meter an air route. There are different ways to meter these things. And that basically just means that you change how fast planes are going or how many planes are coming in or out. Some ways that you meter is by doing cancellations. If you cancel flights, you don't have to worry about those flights coming in at all and clogging up the airspace. Generally, that's a worst case scenario, and the airlines don't like to cancel flights because that makes customers unhappy, and we've all been there. So that's what I learned a lot about doing that internship, was just the national airspace system. And that really made me even more serious about pursuing this as a career field. And so I knew that I wanted to do this. And there's a company based out of Massachusetts called WSI. Some of you may have heard of it. You may have seen their little satellite dishes sitting on top of something in an airport. They were recently acquired by IBM. So technically they're IBM and not WSI, but you probably know of them at this point still as WSI. It was a recent acquisition. So I worked for them for a couple of years. And something that helped me work for them and helped me quickly spin up was the fact that I had done this in the military for so many years. And okay, this peanut butter's done. So with my time in the military, I was able to build the experience that's what everybody complains about now. You have to have 5 years of experience to get an entry-level job. And so that's what the military was able to give me, was that experience. And the ability to read these forecasts, these METARs, these TAFs, how to forecast for icing and turbulence. And some of the products that we used in the military, we also used at WSI. We just made our own products. So I'm going to show you a couple of the products. And if I can get my sharing to work again. There we go. So the METAR, as many of you have probably seen, has anybody not seen a METAR? Okay, that's great. So I color-coded it just in case I needed to do a little bit more explanation. So we've got, I took the Burlington METAR from this morning at 12Z and have the winds from pretty east-southeast at 3 knots. Visibility is 10 miles. Cloud decks, few at 1,500, scattered at 3,700, and broken at 20,000. Does anybody need me to go into how we discern whether it's few, scattered, or broken? I know Jason said that we had some undergrads, some grads, freshman through senior was possible. Okay, cool, thank you. So when we look at the clouds in the sky, we break the sky into 8 pieces. Think of a piece of pie with 8 slices. And what we do is, if we've got none of those slices with clouds in them, that's going to be a clear sky. Sky's clear. And if we only have 1 or 2 pieces of the sky with clouds in them, and it's mostly blue skies, but a little bit of clouds here and there, then we call that few. If 3 or 4 of those slices are full, so if half the sky is full of clouds, that's going to be scattered. And that's how we start to do these tiers. And if greater than half of the sky is covered, but it's not completely covered, it's considered a broken cloud, a broken deck, a broken sky. And completely covered would be an overcast sky. So you can't see any of the blue. So this really just boils down to make the sky look like a pie and figure out how many pieces have clouds. And that roughly describes how we determine what the different cloud decks are. And then we just say, okay, we've got a little bit of the sky covered at 1,500 feet. So that's going to be few. And then we've got another deck a little bit higher than that causes the rest of the sky to be halfway covered. So that's going to be a scattered deck above the few deck. And then what they're saying here is then there's some really high clouds out there that almost obscure the sky, but it's not completely overcast. So that's why we've got it broken at 20,000. That's probably some high cirrus that is just covering up a lot more of the blue sky. So then after the cloud layers, we have the temperature. So we've got the temperature is 12 and the dew point is 9. Then the A3016 is just telling us that the pressure is 30.16 inches of mercury. That's really the meat and potatoes of the METAR, the weather part that we're most concerned about. The remarks give us a lot of additional information. Because this is a 12Z METAR, it's going to have more remarks on it than the others. The 7 group, the 1 group, the 2 group, the 5 group down there later on, each of those is telling you a different piece of information. The 5 group, for example, is called the pressure tendency group, and that lets you know how has the pressure changed in the last 3 hours. So it's additional information that is not necessarily relevant to a forecast, but it's more relevant to keeping an archive and a record of this is what happened over the last 3 hours, or this is what happened over the last 6 hours. And that's what the remarks are usually used for. Now, if there are thunderstorms in the area, you may see a remark saying that there's lightning to the south, something like that. You can do really anything in the remarks that you want to do if you augment the observation as a human observer and just put any information in there that you need. One time I saw a METAR that said cloud looks like puppy. I'm not even joking. So you can do almost anything with the remarks. The portion before the remarks is where the code is very specific and you have to follow the code to the letter. So when we're talking about TAFs, you know, I learned how to write these in the military. And what the TAF is, it uses similar code to the METAR, almost identical. And this is where we give you a 24-hour forecast broken down by hours. So when do the conditions change? That's when we start a new line. So line 1 says that in Burlington as of 12Z, so what is that for you? For me, that's 7 a.m., 8 a.m. for you. At 8 a.m. in Burlington, we had some pretty low winds, variable. VB or VRB is variable, meaning that they can't really pin down a direction. Variable at 3 knots. P6SM means greater than 6 miles, which as far as they're concerned is unrestricted visibility. And then we've got our clouds in here. We're going to forecast a scattered at 2,500 and a scattered at 15,000. So if you go back and you look at the METAR, is it identical? No. But is it operationally similar? Yes. They had variable at 3, and the METAR just gave you a direction at 3 because the METAR is just taking a knob at that one point in time, and that's the direction the winds happen to be coming from. 10 statute miles, well, that's greater than 6, so that's in place. The dog is growling at my cardboard cutout. Stop it, lay down. We had, hey, excuse you, Princess Leia should not be barked at. General Leia, excuse me. What? Go away. The scattered at 2,500. So anytime you have a few deck or a scattered deck, operationally, that is not going to change anything that the airplanes do because they can still see the ground when they're coming in. So it could say scattered at 2,500 and you could actually have scattered at 8,000 and nobody would care. If you had scattered at 2,500, but the actual observation was broken at 2,500, suddenly people start caring because it's harder to see the ground and the pilots need to be able to see the ground to land the airplanes in most scenarios. There are some tools that are equipped on aircraft and at airports that allow them to land in really awful, nasty, soupy conditions, but they don't like to do that if they don't have to. So based on the 12Z TAF, what they forecast, and the METAR that was observed, their TAF is perfectly good. It's accurate, plenty accurate enough to the aircraft that are coming in and out of airports. It's a good TAF. So what they're saying is on the second line, from the 28th at 4Z we're going to have a change in conditions. So this is going to be midnight for y'all. So at midnight tonight, we're going to have a deck of clouds come in that is going to completely obscure the ground if you're flying above 7,000 feet. That overcast at 7,000 lets them know that if they're taking off, they can't see the sky, and if they're landing, they can't see the ground. So suddenly this becomes a little bit more operationally relevant. And that's what we try to do in these TAFs. We try to give them operationally relevant information. Then 2 hours later, they're saying, okay, rain is going to start, and there's a chance for some mist to be present. So BR is mist. That came from a French word. That's why it's BR. And because the clouds are also lowering, we're going to go ahead and, show those as getting lower as the rain starts to move in. Then the last line, the main reason that they would do this line is because now, instead of the winds just kind of varying at a low rate, they're still going to be a low speed of wind at only 5 knots, but now they're locking into a direction. So they want to just go ahead and let people know that, okay, the winds are finally going to stop being all over the place, and they're going to be from the southeast starting at 10Z tonight. So this is what their TAF is saying, and that's basically how you read and or write a TAF. You look and see when the forecast changes enough to warrant letting people know that the weather's changing. So the other thing that we did a lot in the military that has helped me in my civilian forecasting are SIGMETs, significant meteorological conditions. I looked this morning, there are no turbulence or icing SIGMETs currently, so I don't have any slides for those, but they work the same way. These are convective SIGMETs. The red boxes mean that there is a forecast significant region of convection, and that's something that the aircraft need to be aware of. So anyone flying from Houston to Orlando who is going to come across the Gulf and hug the coast on what we call the Q routes is going to find that getting from Houston to New Orleans, where they join up to the Q routes and go southeast down to Florida, is going to have a much more difficult time. They may not even be able to fly through there. The FAA may have closed those routes. So anyone leaving Houston to go to Florida is now going to have to fly north before they can go east and try to cut through the SIGMETs there that are over southern Louisiana and over Alabama. So these are the sorts of things where the weather starts to impact routing. So we need to be aware of where the SIGMETs currently are. In the military, we had to forecast our own. We had to tell them. We couldn't just go to the National Weather Service and be like, hey, the National Weather Service says this, the feds say that, because we're also the feds, and we have to give them our own forecast. And another thing that sometimes pops up is there will actually be a military operating area, and this is really common off the coast of Pensacola area, that all of a sudden this day the military needs this airspace, so all the civilian air traffic has to go around it. Too bad, figure it out, because the military is calling dibs on this today. So there are a lot of different ways that weather can impact things that are not on the surface. You've got what we call clear air turbulence. It's turbulence that you can't see. It's not really necessarily associated with a thunderstorm, which definitely causes turbulence. And it's not necessarily associated with a low pressure system. So when you get north of an occlusion and an occluded front, sometimes it can get a little turbulent up there. So you try to be cognizant of areas that may have greater than moderate turbulence and just steer clear of those, because we don't want passengers to get hurt, and we don't want to have to do an aircraft inspection because that takes up valuable time and resources. So the goal is to avoid the turbulence. Now, clear air turbulence is hard to avoid because you can't see it. There's no indications in clouds because there are no clouds. It's not based around any sort of thunderstorms or frontal zones. And the most common place that we see that is coming off of the Rocky Mountains into the Great Plains. If any of you have flown, say, to Denver or past Denver from east to west, you may have felt that it gets a little bumpy when you're in the middle of the country. Even on a relatively good day, you may get a little bit of bump, some light turbulence that you feel on the plane. because when the jet stream moves from west to east across those mountains, it generates turbulent eddies that then propagate downstream into the Great Plains, and they get larger and larger, and they're basically turned into waves that will rock the aircraft if they hit the right frequency. So those are some things that we have to be cognizant of and be aware of. If the jet stream is strong, you may want to forecast an area of turbulence even if you don't have a confirmed area of turbulence. Now, if an airplane hits a pocket of very strong turbulence, moderate or severe, you're going to hear about it. The pilot is going to tell you. He's going to send what we call a pilot report, or PIREP for short. And the pilot is going to report, hey, 30,000 feet, I've got moderate, occasionally severe turbulence, and this lasted for 3 minutes or something. The pilot reports are written in a code as well, and I didn't have any good PIREPs from this morning. There were a lot of general aviation stuff that wasn't really relevant to a large scale operation like Southwest. It was some reports of light and things like that. Whereas our pilots, you're not going to hear from them unless it's approaching severe level turbulence. And one of the greatest PIREPs I have ever seen was a general aviation pilot in Alaska coming into land and couldn't land, did a go around because he couldn't land, and did a pilot report to tell everybody why he couldn't land. And the reason was baby moose on runway. So again, pilot reports can also be used for a great number of things. You can put anything in the remarks that you think is relevant operationally to other pilots, to the airline, to the airport. You can just, it's kind of pilot discretion as to what they put in these things. And so those are a lot of the components that I learned in the military that I was able to bring to my civilian forecasting. Very basic overview there. It does get a lot more detailed, and there are a lot more products. I just wanted to hit some of the highlights for you. And something that was really cool about the military, I'm just going to take a couple of minutes here and tell you some cool military stories, was that I got to go do combat weather. So with my guard unit, we were an Army support group. Prior to that, I had been air support, so supporting the Air Force. When I changed to Army support, I was then supporting the 42nd Infantry out of New York. Some of you may have heard of them, so I know that's kind of your area. And I got to go down to Florida and do some really cool training. We got to go live out in the field, set up this really neat satellite system called BGAN. And basically it's a portable satellite that you shoot the dish up at the satellite in the sky, download all the weather data to your laptop really quick, and then turn the whole thing off. And then you've got your weather packet on the laptop, so you can do forecasting from anywhere in the world. Now, we don't have the fancy model capabilities when we do anything like that. It's very basic analysis package. It's very basic satellite imagery, and it's really limited data. It's a limited data forecast. So it stretches you and your forecasting abilities and makes you a better forecaster when you have to do these limited data forecasts. Because then you're paying more attention to, this is what the analysis says, and based on my knowledge of the atmosphere, what's going to happen next in this location, in that location? What happens ahead of a cold front? What happens behind a warm front? I have to come up with a forecast knowing that a warm front is passing, and I have really no more data than that other than a satellite image with no heights on it. So that was a really fun thing that I got to do in the military. And there are all kinds of really great career fields in the Air Force. The Navy, Coast Guard, and Marines all have weather forecasting as well. The Army does not, and that's why I was Army support. When the Army and the Air Force split, the Army said, hey, we'll take care of all of the veterinary sciences for your dogs and your animals, Air Force, if you'll do all of the weather forecasting for us. And then we don't have to pull double duty. And we said, okay, let's do it. And it's been like that ever since. Army is vets, Air Force is Mets. And it was a really cool training that I got to do down there. Some of the other neat stuff that you can do is para weather. You jump out of airplanes to go get to a location to do a weather forecast. Special forces weather, which is exactly what it sounds like. Women are still not allowed. Sorry, ladies. And then there is the Air Force also has a few positions that are space weather. And there's an observatory in Hawaii and an observatory in Australia. And that's where you're stationed if you're space weather. There used to be one in Massachusetts, and that one closed down. So there are a lot of different routes that you can take within the military if you decide that that sounds like a fun option for you, a good option for you. And with a degree, you would go in as an officer. And I did not have a degree in weather, so I just enlisted as, you know, an airman basic. So if that's something you're interested in, ask questions. I'll give you my contact information. We can chat offline, and I can tell you more about Air Force weather. So one of the other neat things that I did was I deployed. And I'm only telling you this because I want to tell you a fun weather story and why this is relevant to aviation. While I was in Afghanistan, a blizzard came through. There are military planes out there and there are civilian planes out there. The mail carriers are all civilian, and they go out there and they take the mail from the big bases out to the little bases so everybody gets their letters from friends and family. So one of these dippity-doos decided that he was going to try to come back to the big base in the middle of a blizzard. One, nobody should have released him. And two, he should have turned around and gone back. So he flies to our base and realizes, hey, we're in the middle of a blizzard. And instead of turning around and going back, he says, oh, well, I don't have enough fuel to get back. So again, why do you not have enough fuel to get back? You knew what the weather was here when you took off. There's a lot of go around between him and the air traffic control tower, and the tower calling me, the forecaster on duty, saying, hey, I know the current METAR says this. Can you go do a special observation and change it so that he can land? No. It was seriously 50-foot visibility and 0-foot ceilings. It was honest. We were in it. There's no way that I'm changing this METAR so this Yahoo can land. And he declares that he has no fuel. So the tower says, okay, land at your own risk. So by the time this is over, one of the wings is at the end of the runway, and the fuselage and the other wing is skittered across and landed outside the Met station. He's okay. He's never flying again. But this is why weather is so important. And this is why you have to be able to actually stand up to people when they ask you to change your forecast, change your observation. No, stick to your guns. If you believe this is happening, you stand by it, you own it, and if you're wrong, deal with it later. But own your forecast, and that is the number one rule in weather. Own the forecast. If there's one thing I can impart to all of you, if you become forecasters as part of your career later, own the forecast. Stand by it, believe in it. That doesn't mean that when new model runs come in 6 hours later, you can't say, hey, I'm seeing trending changes that lead me to believe that this is going to happen instead. That's fine. When you've got new data that enhances your forecast and can make it a better forecast, do it. But don't just be wishy-washy and change your mind, this, that, and the other, because somebody says, well, we were really hoping that it would be this. No, it's your forecast and it's nobody else's. So that's the big lesson that I learned that day. Stand by your forecast, stand by your obs, and you're not the one getting kicked out. So, okay. So I guess a few of you may be interested in hearing about civilian airline operations, Southwest operations. I can tell you a lot of goodies about the Southwest operation. We've already discussed a lot of the products that we deal with, the TAFs, the METARs, the SIGMETs. We've got watches, warnings, advisories that we put out. If the National Weather Service drops a tornado watch for one of our stations, say the Atlanta airport is in the watch box for tornado, we'll go ahead and shoot a quick email out to the relevant people, the ground ops there, to the network directors here, and let them know, hey, you know, Atlanta's in a tornado watch. We're keeping an eye on it, but just so you know, be ready. We may have to drop a warning on you at some time in the near future. So we're in charge of making sure that we issue those. We create maps for the entire Southwest airspace. I'm going to see if I can get these maps up for you. I was looking at them earlier, and there was a situation with the uploading software at work this morning, and they were not able to get the new maps uploaded this morning. And unfortunately, that does happen a lot. No, they still don't have the new map. So I'm just going to show you last night's map for today's weather. So let me get over here so I can share this. All right, can you see the map?
Not yet. Yep.
Is it good? Okay. So these are some of the maps that we make at Southwest. So what I'll do when I come in on a shift is I will walk in, get spun up on the weather, say, hey, what's going on? Tell me my hot spots. I'll go over and I'll talk to the supervisors of the dispatch and say, hey, do you have anything going on at stations that the weather is going to impact? Is there any sort of runway maintenance? Do you have your fancy equipment out at any of the stations so they can't land if the ceilings are really low when normally they would be able to? What's going on in the system that's going to be impacted by weather? And I'll get spun up on that. Then I sit down and I start looking at the maps. I make a new set of maps to send out late at night. So this was updated at 11 p.m. last night. So that was not me. I was off, thank goodness. And this is an example of one of the maps that we'll put together. And it's the same sort of thing that you would see on like the Weather Prediction Center. It's got fronts. It's got areas of precipitation, storms versus rain showers. And it's got little labels to tell you when. So this is one thing that we send out when we do our briefings every morning and every afternoon. The maps are part of the briefing package. So this is our Friday weather outlook from last night. So let's hope that they're right, because I'm driving later this afternoon off to the east and I don't want to run into thunderstorms. Then we'll do temperature maps. Just give people an idea of what the high temp is. Because if we've got ground crew out there and say we're in Vegas and it's 100 degrees, the ground crew needs to take breaks to drink water and cool off. And that's something that we take very seriously, is high temps and low temps, to make sure that all of the ground crew is safe while they perform all of their operational duties. Then another thing that we do when we make our maps is we put together headlines. And this is just a quick one sentence synopsis for our mega stations, which you may have heard of. American, Delta, all the other airlines, they have hubs. We don't do a hub and spoke at Southwest. We do point to point, but we do have stations that take in over 200 flights a day. We consider those to be megas. So this is just saying, hey, in Atlanta, you're going to have some intermittent afternoon and evening thunderstorms. Probably not going to be anything to write home about because it's intermittent. So people are going to say, okay, well, I'm going to add extra fuel to all of our flights going into Atlanta just in case there's a storm randomly sitting on station. We need to make sure that they've got holding fuel so they can wait it out and then get in there behind the storm. Or extra fuel to route around the storms if we know there's going to be a line of storms and they have to go north or south to turn around and come back into Atlanta, things like that. Then it's good to know about ceilings. So we've got here Nashville and LA morning low ceilings. That gives them a heads up that, hey, you may have some aircraft that are not able to get in because either the aircraft or the pilot is not rated to land in 400-foot ceilings, or the equipment is out. That's another one of those equipment outages. If the equipment is out, none of the pilots can do it. So we need to make sure that we're ready for any sort of issues that arise from having low ceilings. Now, low ceilings, as we define them in our operation, is less than 1,000 feet. Then, trying to find another good example. Oh, well, down here in the regional summary, we'll also list any sort of issues at our non-mega stations for fog and ceilings, because again, that does impact the operation, usually at startup first thing in the morning. And if you start behind the curve, you're never going to catch up throughout the day. You're going to be behind the whole day. So you want to try to stay on top of it, stay ahead of it, so you never actually fall behind. Then in the regional summary, also just pointing out some stations, Raleigh, Charleston, and New Orleans. These all say, you're going to have some occasional thunderstorms. Occasional for us is more like a scattered to broken. And if you see frequent, like up in the New York and Philly area, frequent means almost continuous, if not continuous. So this being frequent rain showers in the morning for New York, that probably gummed up their works pretty darn good. New York is a real trouble spot for all the airlines, just because there are so many airports all stuck in there together at the same time. So I'll get in, I'll do maps, I'll write headlines, I write TAFs, which, we've already discussed the TAFs, and I'll also be there to do any questions that the dispatchers have. Hey, I've got a flight going point A to point B. Is there turbulence? Yes or no? Or if there is, tell them where it is, tell them the heights. Just little walk-up questions like that. We also do big briefings for tropical storms, for winter storms, and that's another asset that we bring to the company by doing that. Then a lot of the people that we impact just within the operations center here in Dallas are going to be, like I've already told you about dispatch. They need to know what's going on at the stations that they're dispatching to and from. The air traffic controllers work with us and with the FAA air traffic controllers to figure out routing, to figure out whether or not we're going to have any ground delay programs to slow things down to help operations take off more smoothly. Mechanics need to know, again, because they're working out in the heat, or some things are not allowed to be worked on in the rain. They can't do these things if it's wet. Then we've got safety. Here at Dallas, if there's a tornado bearing down on our operation, we're the ones that tell safety that, hey, you need to turn the key and put the walls down, and we turn into an F3 resistant bunker here at the ops center. So even little things like that. Scheduling needs to know, is there going to be a big hurricane? Do we need to bring in more people to work phones? Because a lot of customers are going to be changing their reservations. And it's just, we have an impact with so many different groups. It's kind of ridiculous how many groups that we touch with the work that we do. And the last groups that we really impact are the ones out at the stations, the crews themselves, the pilots and flight attendants, the ground crew, like we discussed, and then staffing at the airports. When Hurricane Florence came in, we actually closed several of our airports a day and a half early so that our employees could go deal with fortifying their own homes and not have to worry about the airport. Other airlines kept flying, but we said, nope, we care more about our people being safe than we do about our customers getting where they're going right now, because if our people aren't safe, then nobody can fly. So none of our customers can fly if our people aren't safe. So that's something else that we have to look at from an operational standpoint. When are the impacts going to start? How soon before the impacts start do we need to let our people go to prep for the impacts? And the stations themselves, how long does it take to close a station? It took Charleston 12 hours to close down, so that those people could then be on the road and getting home plenty of time early to prep their own homes. So it's a lot that we do as forecasters for Southwest, and a lot of these things I didn't do at American. They only used the meteorology for the flights, for the stations, and called it good. I never touched any of those other groups that I mentioned at Southwest. They didn't come ask me questions. In Southwest, it's more like one big family where we all help everybody else and everybody cares about everybody else, which is a really cool concept. And that's one of the great things about the company. You can see where all of your work effort goes and how it helps not only your cohorts, which is what we call our coworkers. You can see how it helps the customers. Give it to social media. They shoot out a big Twitter, Facebook thing. And next thing you know, half of the customers are already advised that, hey, there's storms coming and we're canceling flights. Double check your flight. So that's really kind of Aviation Met 101. And I wish I had another 10 lectures to give you all kinds of details, but I'd rather give you 10 minutes for questions instead. So do you have any questions from y'all? Hey, what you got in the back?
So in terms of your work schedule, What are aviation meteorologists? What is their work schedule like? Is it similar to National Weather Service in terms of shift work?
Yes, 24/7, 365. Yeah, I work nights. I'm usually asleep right now. All right, what you got? Red sweater.
I got a red sweater, among other things. Question about clear air turbulence. Is it the case that to this day there's no instrumentation that can detect clear air turbulence?
What was the last of that?
Is there instrumentation that can detect clear air turbulence?
Some aircraft are equipped with different types of instrumentation. There's AMDAR, there's the pitot tubes. There's some of them have their own radars, and the radars that they use on the aircraft are completely different than the radars that we use here, because they have like straight beam radars, whereas ours go up at an angle to go in circles and show everything. So their radars just shoot straight out, and they can see what's right in front of them. And sometimes you can see a little bit of turbulence, but oftentimes you can't. I don't know if any of our aircraft are specifically equipped with fancier equipment. I think if they were, I would know about it, because our team should know about that. But for clear air turbulence, mostly it's just, hey, I'm in this and I need to get out of it right now. Let's let everybody know it's here. And that's one of the limitations right now of some of our forecasting and some of our models, is that there are still components that are very difficult to forecast.
Clear air turbulence can be detected with radar, but it's very, very difficult.
Right.
The backscatter mechanism is fluctuations in humidity. And so
Right.
fluctuations in backscatter are very small. Plus, the return signal is tiny.
And it determines on how trained the pilots are. Are the pilots trained in radar meteorology so that they can recognize these things when they see it? Usually no.
Okay, just wondering.
They have enough met that if they need to do a quick and dirty forecast, they can look at this stuff and get up in the air. But so there's a lot of meteorological training for both pilots and dispatchers. It's just easier for them if they have us on staff to do all that legwork for them. What you got, front row?
So this past year, did you have any instances where it was simply too hot for the planes to take off? I know there's.
Yes. San Diego, in the middle of the summer, there was a huge heat wave in Southern California. It was like 100 degrees down there. And so what they have to do is, it's not that the planes can't take off, it's they can't take off with a full load. So there are two ways around this. You can either take off load, which means you can't fly everybody and you have to ask people to be willing to not fly that flight and wait and come at another time and give them a voucher. Or you pull off bags and people don't get where they're going with all their stuff. Or we do what's called a hop. We'll pull off fuel instead and take off, get over those mountains, land in Phoenix, refuel, and then have a nice long runway, a longer runway in Phoenix to take off with more fuel to get where we're going. So there's different ways to work around that. None of them are ideal.
Right.
So, but yes, that does happen. And Denver also is interesting, because when it's really hot or really low pressure, it's hard to get the planes off the ground. So they're inversely related. High temps and low pressure make it harder to fly. But it has to be very low pressure. Anybody else?
I'm off the screen here, so I'll move over so you can see me. Oh, this is a really great talk. I appreciate this. It's been really informative for me also as an advisor and faculty member. What pathways exist for students who are not interested in joining the military? What other pathways exist to enter this type of career?
Okay. Southwest does an internship every spring, fall, and summer for the meteorology group. And that's a good way to get really great experience, because by the end of your internship, you're actually making the products, you're doing the briefings, you are doing the work. So you can say you have experience briefing an airline operation, and it's really great. I will send, I think the spring time frame is over. I'll double check those dates as soon as I can and send Jason all of that information. And even though I'm not going to get around to this for another day or two, I will tell you, you can go to the Southwest careers page and all internships are listed in there just like any of the other careers. So you're going to want to look at a Dallas-based internship and meteorology if it's still listed. I know it went up in September. I don't know how long it stays out. If it's still listed, you can apply for a meteorology internship with Southwest. And I don't remember if it was for the spring or for the summer. But the way it works is you come down here, you spend an entire semester here, whether it's fall, spring, or summer, and they pay you. It is a paid internship. You come work for us, we pay you, and you get experience also. So that's something you also have to work out with the university. You know, you're paying for credits for the internship, but you're not taking any other classes, or maybe you are. Maybe there's an online class or two you can take that you don't fall as far behind by taking a semester to go do just an internship program. For those of you who are interested in doing that, definitely go look at the Southwest Careers webpage.
What level of experience is required for those internships? So do you typically take like juniors?
I think it's mainly juniors and seniors. Maybe a sophomore that has extra credits that qualifies as a junior, even though they're only in their second year. I don't know all the details. I know for a fact we take juniors and seniors. And I think our summer intern had just graduated and did an internship as she was starting grad school. So it was like a post-senior internship. We also didn't have anybody else apply for the summer. So we're like, yeah, we'll totally let you do that. So apply. I don't know why nobody applied. So a lot of people don't want to do it over the summer.
We'll definitely list it on our internship site. It's an internal page that we have for our students.
Please do, because most of our internships have been A&M, OU, had a couple of Penn State, Texas Tech. I had one guy from Arkansas. We actually had a Canadian kid in here from Vancouver who did an internship, and he was awesome. So it's not just, U.S. people. And anybody can do it who is a meteorology student. And at least, I think you have to be at least a junior or have at least junior level credits. They want you to have, the bare bones of meteorology behind you, even if you haven't done like the hardcore dynamic stuff.
Anybody else? Go ahead, Francis.
One more question. You mentioned grad school. Is that preferred for a job in aviation meteorology, or could you enter with a bachelor's degree?
It's not required. Only 2 of us on my team have a master's degree.
Okay.
If you're going into the National Weather Service, I highly encourage you to get a master's first because you'll get more points on your application. Yes. If you're joining the military, you only need a bachelor's if you want to be a weather officer. Then yeah, aviation, WSI, also a great aviation forecasting group there, or IBM/WSI. They're based out of Andover, Mass. If you want to stay in New England, apply for them. As far as I know, they have been looking for people lately. So if you're getting close to graduating, maybe contact them, ask them, hey, do you have any positions coming available that are available, things like that. That's how I ended up getting in there.
Thank you.
Yeah, you're welcome.
Well, thank you, Erin. I think that'll do it. So yeah, feel free to send me that information, and I'll be happy to. If anybody's interested in contacting Erin, see me, and I'll relay your contact information to her.
Do that. Send me emails so I have more things to do on night shift. It can get a little boring.
Well, thank you again, Erin. Have a good day.
You're welcome. Y'all have a wonderful day.